Good morning. Today I want to share a vision for React, one where we use web APIs to describe not just web apps, but also native apps, a truly cross-platform future for React. The library that's helping us to explore this future at Meta is called React Strict DOM. In the first part of this talk, I'm going to make the argument that although React for web and native has empowered UI engineers, we're also holding ourselves back in some ways. But by unifying the best of React on the web and native, we can unlock new value and new possibilities. In the second half, I'm going to describe how this vision for React is progressing at Meta and my perspective of its future. As with any idea, it can take time to fully understand and articulate its impact, so today I'll do my best. I want to start out with a little bit of background so you can see where I'm coming from. Let's start with the status quo. React's component model changed how we build UIs. React developers today are productive, but the technology stack is still quite fragmented, both within the web and between web and native. Before you can get started, you have to choose which platform to target, and then learn a specific set of APIs for that platform. This fragmentation leads to hidden inefficiencies and often forces us into tough trade-offs. On the web, React DOM gives developers a lot of freedom, but before you can write your first line of UI code, you're required to make a series of fundamental project-defining choices. Most notably, the choice of how to style elements. CSS modules, utility CSS, CSS and JS, there are lots of options, and every project is the potential for a new debate. And this is because there's no built-in component native styling system for React on the web. The result is significant inconsistencies between code bases and a lack of truly portable UI code. So React's flexibility on the web is a double-edged sword that increases fragmentation and raises the barrier to entry for newcomers. If your product succeeds and you want to go native, you hit a fork in the road. React Native is a different API. Your web code and your knowledge don't transfer so easily. You need to learn new elements, new styles, new paradigms, and more often than not, React Native apps are rebuilt from scratch. And this isn't just a web-to-native problem. Many React developers start first with React Native, and they face similar challenges when moving to the web. So there's no common way to describe and build React apps, even on a single platform. And this technical fragmentation has become a tax on developers and a source of community fragmentation. It's also increasingly clear that fragmentation is a significant drag on our ability to best leverage emerging technologies like LLMs. So this isn't simply a technical problem, it's become a product and a business problem. Doing similar work more than once, often across separate teams and code bases, results in slower time to market and product inconsistency. So this is how I see the state of things today. But what if we could unify and standardize these different React worlds? Just one way of using React to build UI across all platforms. No more forks in the road, no more choosing between one platform and another, no more choosing how to perform common tasks that are universal to UI development. This is the motivation behind Meta's effort to create an in-house cross-platform React framework. And React Strict DOM is a key part of this framework. It's built on top of React DOM and React Native, but it unifies the way that we describe UI using React. This lets us develop a consistent product vision across platforms while still delivering platform-native capabilities. To understand why we're having success with React Strict DOM, I first want to talk about other ideas we tried and why they fell short. We experimented with several approaches to cross-platform React, and each taught us something important about what works and what doesn't. The first thing we considered was using React Native to build cross-platform apps, including for the web. React Native for web already exists. It's been around for nearly as long as React Native itself. It implements many of React Native's components and APIs for the web, and it's become part of Expo, the default React Native framework. But it wasn't the right fit for us. Three things made it impractical. First, when we ran existing React Native code on the web, the output didn't meet our standards. The experiences weren't accessible or responsive enough without substantial rework of the original code. Second, The majority of our screens and our components are already built for the web, so adopting React Native would mean asking most of our engineers to switch to a less familiar API. And third, React Native's component API hasn't evolved much over the past decade, and it never really became a common choice amongst web developers. But what works really well is React Native's styling system. It's enabled an ecosystem of portable, composable components that just work together, and that's something that we think is worth bringing to React on the web. Next, we tried another approach. Build a new cross-platform UI component library, different from both React DOM and React Native. We started simple, just replace div with a new cross-platform flexbox abstraction called box. But this also didn't pan out. We still needed major code changes, and it introduced visual regressions at an alarming rate on the web. We had to design, build, and learn an entirely new UI library before seeing the benefits of code sharing. So the migration overhead was pretty high, and the value remained distant. And if that level of effort didn't make sense at meta scale, it was hard to imagine it working for the broader React community as well. So how could we find a way to minimize the migration costs while still getting the value of code sharing? So instead of pursuing an approach that would require rewriting code, we revisited an idea that had previously been discarded as unrealistic, using our existing web code to build native experiences. This was the core idea behind React Strict DOM, because our web code already describes how we want an interface to work. We want to be able to render our web code on native as is, with minimal changes, and for the migration of components to be safe, reliable, and fast, taking minutes, not weeks. But our goal was not just to write once and hope for the best. We want to be able to run once, write once, run everywhere, and still get a top-tier experience on every platform. So native apps must still look and feel native because the UI has to be truly native and not rendered using web views. So one of the biggest wins of this approach is that web developers, who make up 90% of the React ecosystem, can build native apps using the APIs they already know. People can rely on their knowledge of the most widespread and well-documented APIs of any platform, which is the web platform. No major retraining is required. We just unlock the potential of people's existing knowledge and skills. And React Strict DOM isn't just good for people who've invested in the web ecosystem. It also allows React Native to focus more on its core value. The new architecture of React Native makes it possible to have a convergence with the web that was previously out of the question. We don't need to invent and maintain a separate native-specific component library. And React Native's API design work can focus on what's needed for the rich native code integrations that only React Native can deliver. Standardizing on web APIs can expand React Native's audience to include web developers as well. So React Strict DOM started as a prototype of this vision to use our existing web code on native. It connects React Native to React DOM with an API that's immediately familiar to web engineers at Meta. It exports two main modules, HTML and CSS. The HTML module is a cross-platform subset of components from React DOM, and the CSS module is an enhanced cross-platform version of Stylesheet from React Native. On the web, React Strict DOM intentionally does very little. The components look nearly identical to React DOM. The differences are small but deliberate. We have props that are strictly typed, and the style prop works like it does in React Native, providing encapsulated and predictable styles. On native, there's a bit more work happening. We map web APIs to native APIs, and even component instances have most of the properties and methods that you'd expect from HTML elements. But the rendering stays true to each platform. Web still produces HTML, and native apps still produce native elements. Because React Strict DOM doesn't try to fake one platform and another, it just creates a shared interface between them. The styling system preserves key features from React Native: style encapsulation and predictable merging. When you compose style components with React Strict DOM, you know what you'll get. And that's been the standard in React Native for a while, but it's harder to achieve on the web. At Meta, we've approximated this with StyleX. The API is very similar to React Native Stylesheet, but there's support for more CSS features, as long as they don't compromise on encapsulation. So React Strict DOM combines the best of both: the constraints from native to enable reliable composition, and the broader CSS capabilities that we're used to on the web. What you get is components that compose predictably, code that moves between platforms, and the kind of ecosystem portability that React Native has had from the beginning. This convergence with the web is thanks to advances in React Native that now make the details of this cross-platform vision a possibility. The new React Native architecture unlocked the ability to provide synchronous APIs and call directly into native, just like you would do in the browser. React Native now supports the same event loop and DOM traversal APIs that you find in a browser environment, as well as an increasing number of CSS properties, like box shadows, filters, and background image gradients. We're also experimenting with native versions of web APIs like Mutation Observer and Intersection Observer. All of this lets us reproduce web components on native more accurately than ever. But React Native doesn't support everything we need just yet. And so React Strict DOM also polyfills web capabilities like CSS custom properties, CSS inheritance, relative units, CSS transitions, and more. About half of the APIs that are currently available are polyfilled in some way. And this helps us bring more of the power and familiarity of the web to native platforms without waiting for every feature to be moved into native code. All of this work to create a shared interface based on the web means that we can now easily transform lots of existing code and make it work on native. We use code mods to automatically convert React DOM to React Strict DOM. And while some manual refactoring is required for edge cases, code migration has been really easy to automate. And this was a key win over previous efforts that required mostly manual migration or re-implementation of components for native. At Meta, our use of StyleX with its similar syntax to React Native style sheet made this migration especially easy for us. For any React web code that's using another styling system, the work to transform styles might be a little bit more complicated. But once that's handled, the rest of the journey is pretty easy. The same approach works for React Native. We have teams that also want to migrate existing React Native components to the web. So we built a code mod pipeline to automatically convert those components to React Strict DOM as well. The first apps that we built this way have to run on native devices with very limited hardware. So we've also made extensive use of the new React Native dev tools and React Native's internal benchmarking tool to find sources of performance loss on native. And this is helping us to optimize the JavaScript polyfills and to identify features that would most benefit from being moved into native code first. And although the goal is to enable as much code sharing as possible, there are still cases where we want to use platform-specific APIs or optimizations. And for those, we use platform-specific file extensions to fork code and go fully native as necessary. This is already a well-established practice in the React Native ecosystem, and it's worked well for us in a cross-platform context with the web as well. So we've been building cross-platform apps this way for about 2 years, and I can share one example here today. The Facebook VR app shown at Meta Connect last year was the first native app built from existing web code using React Strict DOM. It made it possible to ship features faster with fewer engineers and to produce a more consistent experience across platforms. The app reused some of the most complex and robust features from Facebook.com, like the newsfeed and commenting. And by sharing code in this way, teams spent less time on repetitive business logic and user interfaces, and more time on building MetaQuest-specific interactions and experiences. So what's notable isn't just that we reused web code, it's that the resulting native app looks and feels pretty much indistinguishable from one that would be built natively. And this proved to us that sharing code with the web doesn't have to mean a compromise on product quality. About 60% of the files used by FPVR are shared with the web. And although React Strict DOM is still just a drop in the ocean of Meta's overall React use, it's already rendering about 10% of the divs and 20% of the spans on Facebook.com's home feed screen. We almost entirely avoided visual regressions and saw no performance or user experience regression on the web either. So unifying React code in this way brought many benefits, especially for the web, but it's also had some trade-offs. The most significant trade-off is the runtime cost on native of polyfilling so many missing features in JavaScript. Adding these extra capabilities to native means that rendering a div is about half as fast as rendering a view. And although we found that this performance cost is generally acceptable, even on relatively low-end hardware, we continue to find ways to do better. And in the last 18 months, we've improved the performance of React Strict DOM on native by about 2.5 times. And this is not a static number, because over time, as more features are moved into native and the code is optimized, this gap will continue to close. Another missing piece of the puzzle is how to make unit testing of cross-platform components just as easy as it is to create them. This is not yet solved to a satisfactory degree internally, so it's something that we still have to explore and invest in. Other than tackling these trade-offs, what might the future look like? Christopher Trudeau once described React Native as an experiment to figure out the good parts of the web. But today, React Native is no longer an experiment, and it has many other goals beyond this early aspiration. Now, React Strict DOM is this experiment. And the future is not guaranteed, as it needs people to continue investing their time and creativity into this problem. But this is what I think about when I think about what could be next. First, React Native needs to become a selective, high-performance web renderer for the well-defined subset of HTML, CSS, DOM, and other web APIs that we need. We currently support or emulate about 63% of the target API on native. And if we can unify more features, especially styles and events, we can close the gap between platforms and further increase the value of this approach to cross-platform React. In the past, this seemed implausible, but as you heard earlier today, the people working on React Native have shown that it's now not only possible, but beneficial for us to do this work. Next, we're also experimenting with cross-platform animation APIs. On the web, this is powered by the Web Animations API, and on native, the core is now written in C++. So this means both platforms can rely on native code to drive smooth animations. And there's also more work to be done to deliver an integrated cross-platform styling solution for React. We've made a good start, but there's still a lot of feedback from internal teams that we need to incorporate into future iterations. Because our goal is not just to create another UI library. It's about consolidating our entire approach to building user interfaces with React. And it's only possible now because of the accumulated progress that you've seen across React, React Native, React DevTools, Hermes, Flow, Expo, and other technologies. Improvements to each part of this stack have multiplied the value of the others. So today, at Meta, we can build and share things that would have been impractical just a few years ago. So from that foundation, 3 goals for React Strict DOM emerge. First, move towards a single canonical way to build UI with less fragmentation and less duplicate effort across platforms. Second, give web developers a strong default with the kind of built-in component-native styling that React has always deserved. And third, establish a foundation for consistency and quality across teams, platforms, and products. When there's one clear way to describe interactive interfaces, all of our tools, training, and investments can compound in the same direction, and that's where the real value appears. And if we can also train AI systems on more consistent patterns, we can make sure that React continues to be the most effective way for people to build UI with unprecedented accuracy and portability. As code generation becomes a core part of modern development, it's critical that generated UI looks and works the same across all contexts. Inconsistent rendering or incompatible components undermine the promise of automation. By evolving our frameworks with clear and well-defined APIs that LLMs can easily use, we might be able to build user interfaces that better match our intent, no matter the platform. So what I'd like you to take away from this talk is the following. The effort to create one React for web and native is helping Meta to build new experiences as cross-platform apps. And we think that this is a key advantage for the future. Standardizing on the web lets us capitalize on the enormous existing adoption of React on the web and the API design work that's gone into the world's most ubiquitous application platform. When we constrain how we build, we can create trade-offs that work in our favor. And trading some flexibility to increase predictability is what lets us compose large systems with more confidence. React Native is where we need to build more capabilities if we want to deliver on this potential, and I think you saw that that's what we're doing. And finally, the nature of generative AI can inspire us to make simpler and better frameworks that help people using AI models have more success. One of React's great strengths is its large and passionate engineering community. And this community's actions, creations, and feedback help shape React and React Native more than you might realize. So if this is a future for React that inspires you, I encourage you to help make it a reality. Thank you.